Hello and welcome to the first of three films about chemical reactions and equations. This first film is an introduction and it really deals with just the main types of reaction that you can expect to see and expect to have to write equations for in your semester 1 exams. Hopefully by the end of it you'll have started to see the kind of patterns you need to spot before we actually move on to writing equations. So there'll be no equation writing in this particular film. Okay, so we'll look first of all at the main reaction types. Now there are others that you might get examined on, but not in semester 1. Okay, so we're going to be looking at the reactions of acids, with three main groups of substances: metals, bases and carbonates, and we'll also be looking at precipitation reactions. Okay, so before we start looking at all those things, these get referred to quite a lot, the negative ions that we find in acids. So it's worth just looking at what they are before we start. Okay, there's a chloride ion in hydrochloric acid, which means we often make chlorides when we use hydrochloric acid. There's a sulfate ion in sulfuric acid, so we make sulfates. A nitrate ion in nitric acid, so we make nitrates. And an ethanoate ion, it is there, CH3COO-. So when ethanoic acid loses its H, we've got an ethanoate ion. Notice there, the negative ion that we've got in acid is what's left after we've removed the H's, so after the H plus of the acid has reacted. Okay. So off we go. Let's have a look at the first group of reactions, and this is acids reacting with metals. So first thing to note is that whenever an acid reacts with a metal, you're always going to produce a salt and hydrogen. There are metals that acids won't react with, such as gold. Silver doesn't react terribly well, and copper won't react with a lot of dilute acids. But if you do have a metal that reacts with an acid, it will produce a salt and hydrogen, and the name of that salt will depend on the metal that you've used and the negative ion from the acid. So for example, if we use hydrochloric acid and magnesium, okay, pretending that this is a chemical equation, we're going to end up with magnesium chloride because we've got the negative ion from hydrochloric acid, so magnesium chloride and hydrogen. Okay. Remember, I'm just going to write it as H2 here. Remember that it is a diatomic molecule. Here's nitric acid. That's got a nitrate ion, so when reacted with calcium, you're going to make calcium nitrate. And because this is an acid reacting with a metal, you're also going to form hydrogen, okay, which I'm abbreviating here in my word equations to its symbol. All right, but if you're ever writing a word equation, you ought to write that out as a word. Okay. So that's acids and metals. Moving on to the next group, which is acids reacting with bases. Now bases in general are metal oxides and metal hydroxides. They can sometimes be solids in the case of metal oxides, or they can be metal hydroxides, which are sometimes solids or sometimes solutions. Regardless, if you react one with an acid, you're going to make a salt again, and you're going to make water. Naming the salt is exactly the same as it was with the metal. You still put the metal in front of the negative ion from the acid, but water is the other product now instead of hydrogen. So sulfuric acid and copper 2 oxide will make copper sulfate because we've got a sulfate ion here, so copper sulfate. Okay, all we are doing in this film is just saying what the products will be. Okay, we'll practice writing these equations later on in the next couple of films. Okay, and water is the other product here because we've got an acid and a base this time, not a metal. Okay, this acid, ethanoic acid, has an ethanoate ion. Here's the metal, sodium, so this is going to make sodium ethanoate. Okay, and how do we know that water is going to be the other product? Well, because we had a hydroxide, so we're thinking, oh, that's a base, it's not a metal, it's not carbonate, and carbonates are coming up next. Okay, so here are acids reacting with carbonates. Equally well, you could have a hydrogen carbonate reacting with an acid, and the products will be the same. Writing your equation will obviously be different, but the products will be the same, and the products are, again, a salt and water, but now the carbon here is giving us a clue that we're also forming something else, and that is carbon dioxide. Okay, so the name of the salt depends on the metal and the negative ion. That's like it was before. So hydrochloric acid and copper carbonate, well, they're going to make copper chloride because we've got the chloride ion in hydrochloric acid. And we're going to make H2O, water, and we're going to make CO2, carbon dioxide. Okay, so we're going to see fizzing here, just like we would have done with the metals because they were producing hydrogen. So you're going to see fizzing if a gas is formed. Okay, ethanoic acid, ethanoate ion, and sodium hydrogen carbonate, that's going to make sodium ethanoate as our salt. Okay, so see, with the salts, it's always the metal followed by the negative ion from the acid, and water and carbon dioxide. Okay, I'm doing something very, very naughty here, which is writing symbols in word equations. Okay, but I just want to get through this quite quickly, so the film's not too long. All right, really, symbols belong in symbol equations and not in word equations. All right, you ought to write the names of these things out in full if you're writing a word equation. Okay, precipitation reactions. Well, what does this mean? Not an acid reaction. Okay, spot. Basically, a precipitation reaction will happen if you haven't got the combination of substances that will give you one of those three acid reactions we've just seen. Okay, doesn't mean an acid won't be present. It just means there won't be a metal or a base or a carbonate for the acid to react with. Okay, so we're just going to simply here, we're just going to swap the negative and positive ions to find out what our products are going to be. Okay, so whereas before we had salt and hydrogen, salt and water and carbon dioxide in order to predict our products, here we just swap the positive and negative ions, and the precipitate that we form will be the insoluble combination of ions. We've touched on this in the series of films about solutions and precipitation reactions. So here we are. Here's a couple of examples. Lead nitrate and sodium carbonate. We swap the positive ions, so we'll end up with sodium nitrate and lead carbonate. Okay, so sodium nitrate and lead carbonate, because we've just swapped the ions round. Okay, and in this case, actually, the lead carbonate would be our precipitate, because we can look up on our data sheet that that's an insoluble compound. Okay, here is an acid. Okay, so I've deliberately put this in so we can see that acids can take part in precipitation reactions. How do we know it's going to be a precipitation reaction? Because we haven't got a metal or a metal oxide or a metal hydroxide or a metal carbonate or a hydrogen carbonate. So we haven't got one of those three groups of compounds that we just looked at. Okay, we do still have positive and a negative ion here. Okay, H plus and Cl minus. We swap them over, so we're going to get H plus and nitrate. That makes nitric acid. So once again, I'm just writing word equations here. We'll practice writing symbol equations later. And the other product is going to be silver chloride. Okay, so this isn't an acid reaction, in spite of the fact there was an acid there. It's a precipitation reaction, and the silver chloride is insoluble, so it's going to be our precipitate. Okay, once again, this is all about practice. Okay, if you don't remember these straight away, which you're unlikely to remember every single group straight away, then just get some practice done, and pretty soon these things will become second nature, and they shouldn't be too hard. Okay, the next couple of films are actually going to look at writing equations for these kinds of reactions. So it's going to get a little bit harder. It's good if you know the patterns before you start those films.